Hey everyone, so this week is going to be about iteration, and it really builds off of what we started last week with function writing, and sort of now taking it to that next level of, okay, well, what if we want to do something again and again and again in our code? So this video is going to focus on for loops, and it's going to sort of introduce what for loops are. And then in class this week, we'll actually play around with kind of taking it to that next level of also doing for loops and functions together. And then the second video for this week is going to go over map functions. So the data that we're going to need for this video is called Iris, and it's just already in base R. And so you can just call up head of Iris and it will show us what the data looks like. So we basically have some information about different irises, species, and then we're also going to need the MT-CARS data, which is just a CARS data set that we've worked with before in class. And one thing to note is that each row actually has a name to it, and that will be important later down the road, but just a function of this specific data set. And I also want to go over some, or a little bit of a refresher of subsetting, because the last few weeks we've really been doing it in tidyverse and using select and filter functions. And so as a reminder of how we can use square brackets to index for indexing, because this will kind of set the stage for understanding for loops. So we learned way long ago that we can use square brackets like this to pull out information from data frames. And so when I do iris of 1, there's a lot of data here, but it pulls out the first column in the data frame, sepal length. If I were to do double brackets, it would actually pull out the vector of values from that first column. This is the same exact thing as if I were to go iris $ sepal length. It also gives a vector of values in that column. And we also learned about how in square brackets, there is a way to call up rows if it's before the comma or on the left side of the comma, or a specific column if it's on the right side of the comma. So say I also want to pull up that column, I can use this form of indexing to gather that vector of values. And if I wanted a specific value, I could type in the row and column and get one value out. This would be the same as actually calling on iris $ sepal length and indexing for the first value in this column. So we can see this gives us the same answer. And so this is important when we're thinking about for loops, because essentially what we're doing with for loops is trying to recreate a process down all the rows of data in your list or your data frame, or whatever your input object is. And so it takes an index value, and then that's what it uses to run through the function or whatever you have inside of your for loop. So for instance, the basic syntax for loops starts with a for, and then open parentheses, I in 1 through 10 as an example, and then we do curly brackets just like we did for creating a function. And let's just have it print all of the indexing values so we can see exactly what's happening here. So essentially what we've done is we've said for every index value in the range from 1 to 10, print that value. And so we have on the output a value for every single I in that range. And we can see that also this automatically gets stored into our environment. But the interesting thing to note here is that what's stored is the value 10. And so this is storing that very last value that went through the for loop. And so a key difference here from when we wrote a function, we ran it, nothing was actually stored in the environment automatically. Where in this case, something is stored and it's that last value. And so the benefit of for loops is we can actually write in, different, what's the right code or like things that we want to do with the data. So say we want to look at the first 10 values of sepal length in the data. We could say for I in 1 through 10, print those values. And the output is a list of 10 values. And we can see if this in fact matches up with using the head function and selecting for those first 10 values. And in fact, it does. And really the benefit of for loops is that we can do multiple things at once in them, and they can end up being quite complex. So far we've just added one line of code to include in the for loop, but say we wanted to do an additional thing. We actually wanted it to also print from the MT-CARS data set the miles per gallon for the first 10 rows of data. So we can run this for loop and examine the output. And we can see here that there are 20 values, and each output is actually alternating between the two lines of code we've written. So the first value is from the iris sepal length data frame. The second value is from the MT-CARS data frame, and so on and so forth. So one other important thing, and we kind of touched on this last week, is it's really important about where your cursor is placed. So like if I place my cursor at the end of line 37 and I were to run this line of code, it actually runs on its own and it prints out this value that is the same value that we got at the end of when we ran the whole for loop. And so this is basically just spinning out the very last value in the for loop function. So it essentially is taking 10 and placing it into this line of code. So if we ran that, it would give us the same output. But what if we actually wanted to store the output? We wanted to know what the values were in a more systematic way. So the first thing is that you have to think about what you want your output to actually look like. And in this case, say I'm interested in creating a vector of values related to the MPG in this data frame. So I can create an output that I want to call results. And I'm going to just make an vector filled with a bunch of NAs. That's actually the length of the data frame. And this is a function that you all have seen before, nrow. And essentially it counts up how many rows are in whatever object you feed it to, and that's the number that it will repeat NAs for. So if we just highlight that and run it, we can see that it is 32. And so then we can expect our output for results to also be 32. And it is. So say we want to write a for loop that actually goes through every row in the MTCars data set. And for each row, we want it to store the value calculated when we take weight at each index value and times it by 100. And I've chosen to use nrow MTCars here as sort of a more robust way of coding this. So this is a soft code. It is changeable depending on how the MTCars data set changes. I could have also put the actual length of MTCars here, so I know it's 32 rows long, but I want it to be able to respond if anything were to change to the data set. So nrow is a really common way that people would specify a for loop. So if we run this, we can then look at the output. And now we see that we have a list of 32 values, which if we were to look at just the MTCars weight column, we can see that this lines up with what we would expect. It's each value in a row times 100. And so this is kind of the basics of for loops. We're gonna in class like work through this a little bit more, but this is the general idea. And so another family of functions that are from the tidyverse that do that think about this in a similar way, but are applied in a slightly different way is the map family of functions. So I'm going to be talking about that in another video just because this video is getting a little long, but make sure to check that out after this one.